Hi guys, welcome back to Chemistry with Organic Chemistry course. So for today's video, I'm going to discuss the nature of matter. So after this video, the viewers are expected to understand the different state of matter, differentiate physical and chemical properties, list the four state of matter and give examples of each, state in a concise form the organization of matter, and classify matter in pure substance or mixture. So now let's begin in particulate nature of matter. So matter is described as anything that takes up space and composed of tiny particles called atoms. So originally, there are three states of matter, but in this subject, we are going to tackle the four states of matter. So the first one is the solid. Solid is a state of matter characterized by particles arranged such that their shape and volume are relatively stable. In a short meaning, this is a rigid substance with definite shape. So for example, the ice. Then second is the liquid. Liquid is a substance that flows freely. It has a fixed volume but flow to assume the shape of the containers. So for example of this is the water or oil. Then for the gas, a substance or matter in a state in which it will expand freely to fill the whole of a container having no fixed shape and no fixed volume. So last is the plasma. In biology, plasma is a clear, straw-colored liquid portion of blood that remains after blood cell, white blood cell, platelets, and other cellular components are removed. It is the single largest component of human blood, consisting or comprising about 55% and contains water, salts, enzyme, antibodies, and other proteins. But here in chemistry, we define that plasma is a state of matter consisting of free charged particles. For example of these are fluorescent lights, nuclear fireball, lightning, solar wind, and northern and southern lights. So this is the simple illustration of how to differentiate the four phases of matter with the presence of heat. When the solid hits its boiling point, it turns into liquid. And when the liquid constantly heated, it becomes gas. A plasma may be produced when tremendous heat is applied to gas, causes such vigorous collision between its atoms and molecules that electrons are ripped free, yielding the requisite electrons and ions. So this is a similar process occurs inside the star. Now let's move on to the physical and chemical properties of matter. Physical properties of matter can be observed or measured without changing the composition. It is used to observe and describe matter. Examples of physical properties of matter are the appearance, the size and the shape, texture, is it smooth or rough, the color or luster, the way light interacts with the surface of matter, the melting point, boiling point, density, solubility, the ability of solid, liquid, or gaseous chemical substance to dissolve in solvent, electrical conductivity, and malleability, the ability to hammer, press, or roll into thin sheet without breaking. So, chemical properties of matter, it describes the ability of substance to change into new substance or substances. Chemical properties can only be observed when a chemical change occurs. The example of chemical properties are combustibility, the ability of a substance to react with oxygen and release heat and lightning energy or light energy. Example, you are burning a campfire until such time nothing is left and ashes left. So that is combustibility. Then reaction with acid, ability of a substance to react with an acid and produce a gas. And corrosion, ability of metal to react with air to produce metal oxide. Chemical change, a change of one substance in a material to a different substance. If an element or compound undergone changes and form a new product, chemical change happen. In chemical change, the atom present in compounds are changed into a new and unlike compounds. So there are many signs that can tell you when a chemical change has taken place. So one is the smell in the air, production of energy, and the burning and rusting are chemical change or changes because different substances are produced. So next is the classification of matter. So matter has two classification, the pure substance and the mixture. So we will discuss first the pure substance. Under pure substance, we have element and compound. So what is pure substance? Pure substance cannot be broken down into any other substances by chemical or chemical means. So pure substance, under pure substance, we have element and compound. So element is the simplest form of pure substance. They cannot be broken into anything else by physical or chemical means. So it is composed of identical atoms. Example of this is the aluminum foil. While compound is also a pure substance, that are the unions of two or more elements or a combination of two or more elements. They can be broken into simpler substances by chemical means. So chemical bonds hold the element together to form a compound. So example of compound is the NaCl or sodium chloride or the table salt. So before we proceed to the next classification of matter, I have Venn diagram here discussing the relationship of elements to compound, compounds to mixture. So elements, it is a simpler or simplest form of pure substance. Only one kind of atoms. Atoms are bonded if the element is diatomic or polyatomic. Then, compound is two or more kinds of atoms that are bonded. Then, when a compound combine with different compounds, it creates mixtures. So, mixture has two classification or subdivision, the heterogeneous mixture or the homogeneous mixture. So mixture, two or more substances that are not chemically combined with each other and can be separated by physical means. So the substances in a mixture retain their individual properties. So types of mixture are heterogeneous mixture and homogeneous mixture. Heterogeneous mixture, a mixture that is separated into different regions or phases that have different composition or properties. Then homogeneous mixture, a mixture that is uniform throughout and has one phase. So before we proceed to the examples of heterogeneous and homogeneous mixture, let me introduce to you all the Tyndall effect. Tyndall effect is the visible scattering of light along path of beam caused by discontinuities such as suspended particles. So this is the one way to determine if the solution is heterogeneous. Okay, let's proceed to example of heterogeneous mixtures. One or first is the colloid. Colloid has a medium-sized particles. So there is a scattering of light. So it means that there is a Tyndall effect. So example of this is milk. So milk is heterogeneous mixture. Next is suspension. Suspension has large particles, and then particles settle. So there is also a scattering of light or Tyndall effect. Example of this is the fresh squeezed lemonade. So this is another illustration of how to differentiate the elements, compound, and mixture. So for the first bottle, the bottle 1 has only hydrogen atom. Then on the second bottle, there is a presence of water. Water is composed of H2O, or 2 hydrogen and 1 oxygen atom. Then on the third bottle, they have a mixture of hydrogen and oxygen. So showing here is the organization or the flow of matter. So matter can be gas, liquid, solid, or plasma. So under matter, there are two classifications: the pure substance and the mixture. The mixture can be separated by physical means into pure substance. So under pure substance, we have compounds and elements. Element cannot be broken down, but compound does. Compounds separated by chemical means into elements. So under mixture, we have homogeneous mixtures and heterogeneous mixtures. This slide is showing the difference and the similarity between the mixture and compound. Now I will test your knowledge in identifying the pictures on your screen. Find out where they belong. For the first picture, is it homogeneous or heterogeneous? So this is heterogeneous. Second picture, also heterogeneous. Then third picture is heterogeneous. So these are all heterogeneous. Okay, so thank you for watching this video and have a good day.